Welcome to Emtron Training Part 27. In this training tutorial, we're going to be taking a look at our prime pulse, cranking fuel, after start fuel, and warm-up enrichment, and learn how all of these are needed to get an engine to fire up and run at an appropriate lambda target. We're going to have a lot to cover. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at our prime pulse, cranking fuel, post-start enrichment, and warm-up enrichment. Now, understanding how they all fit together to get an engine to crank, fire, and run, whether it's cold or warm, because there's going to be distinct fuel needs that are different on a cold engine compared to a warm engine. Now, before we go in and start to talk about any of those tables, I want to just go over the basics here within the Emtron between our fuel and airflow modeling. We're going to be probably reciting this many times in many other videos. We've had dedicated videos of taking a look and talking about the various airflow modeling options that we have in our Emtron, but it's important to understand these basics when moving into a video like this, because we have compensations that are going to be applied on top of what's going on here and calculated, whatever it's going to be in our fuel and airflow modeling, things that are going to be adding additional fuel on top of that. So it's important to understand the basics and then applying those type of compensation factors on top of what's going on here in terms of fuel and airflow modeling. So the underlying equation we have in our Emtron is fuel mass is equal to air mass divided by target air fuel. In this situation, we either measure the air mass or we're going to be estimating the air mass with our Emtron, depending on what type of airflow strategy we've chosen, whether it's going to be speed density, throttle mass flow, or mass airflow sensor. So depending on what those are going to be, it'll determine what the air mass is going to be. So looking at what I have open on screen right now, this is our main VE fuel table. This is an estimation of airflow. We've talked about this in completely separate training tutorial, but just to kind of recap this is an estimation of airflow. We'll find that this will be part of the air mass determination. So we have our equation again, fuel mass is equal to air mass divided by target air fuel. This would be an estimation of air mass. It starts to allow the Emtron to calculate air mass. Now, we'd specify the target air fuel from our target lambda table. Knowing what the air mass is, dividing it by the target air fuel gives us fuel mass. We turn the fuel mass into an injector pulse width by knowing our static flow of the injector, also knowing our injector characterization data, which is going to be our latency and our short pulse width. Add all that together, it gives us a corrected injector pulse width to pulse at the injector, to send to the injector, to open and close, to deliver the fuel mass that we're expecting with our Emtron. And then we'll find if everything's right, if everything's balanced, whether we're measuring the proper airflow or estimating the proper airflow, and we specify the target air fuel and our injector data information is correct, we'll be having our equation balanced, meaning we're estimating airflow, we're giving a target that we want to run at for air fuel, and then the fuel mass will be sprayed into the engine and we hit the target air fuel. Equation is a bit circular, but the way it's going to work, it's going to be balancing itself out as long as everything is going to be accounted for properly. Now, this is going to be assuming that the engine is warm. When the engine's cold, we have another factor to be able to deal with, whether it's going to be under cranking conditions or when the engine cranks and fires and runs and it's running for the first couple minutes as it's coming up to operating temperature. We have something known as a wall wetting effect. The wall wetting effect is going to be when we have fuel as it's sprayed from the fuel injector, as it's pulsed open is where we would normally expect on a warm engine. On a cold engine now, we spray the same amount of fuel. And we'll find that we don't hit the same target air fuel that we'd expect when the engine is warm. And that's because this wall wetting effect, the fuel isn't going to be spraying out of the injector and atomizing very well. It's going to be sticking to the intake track and to the intake valve. It's not going to get into the engine as efficiently as it did when the engine was warm and the atomization was much better. As a result, we need to be able to compensate for this, whether it's under cranking conditions or whether it's when the engine fires off and it runs for the first few seconds, or even as it's coming up to operating temperature. We have compensation tables, which are our prime pulse, cranking fuel, post-start enrichment, and warm-up enrichment. These are unique in how they're applied in sequence to each other, so they have to be applied in very specific sequence in order to achieve those results and overcome that wall wetting type of effect that we have potentially going on. So the main fuel table here, or the main airflow estimation, this always is going to assume that the engine is up to operating temperature. So the engine is at 60, 70, 80 Celsius or 170, 180 degrees Fahrenheit in coolant temperature, that in that conditions, in those specific conditions, we'll find that the engine will be mostly out of that wall wetting effect. There's always going to be some wall wetting effect. It's never going to be perfect. Fuel isn't going to always make its way right into the intake valve it's always going to stick a little bit, but there's much less of that.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.